Hey guys, this is Unit 3, Linear Functions, still 3.3, and instead of substitution, this is solving linear equations systems using elimination. So we've talked about how to use graphing to solve systems and then substitution, and now we're going to talk about when and how to use elimination. So like we said before, there are certain equations that are better to use for others. Substitution we want to use when there's already a variable isolated. Graphing when we want to use inequalities or when they're both already in y equal form. And now elimination. So if we can't graph them and we don't want to use substitution, we want to use elimination. So if you look just really quickly, let's solve those first two equations. X plus 7 equals 9 and x minus 5 equals 12. If I was to solve for these, I would have to subtract 7 on both sides or add 5 on both sides. The reason I want to do this is so the left term cancels out and x remains by itself. So if you see this arrow here, I want you to be sure the reason we did those two examples is because you need to remember that you're always using inverse operations to cancel out when you're using elimination. So if you have a positive amount, you need to make the opposite negative. If you have a negative amount, you need to make the opposite positive. So let's look at example 1. Example 1 says 5s plus 2t equals 6 and 9s plus 2t equals 22. Now, I see two things here. First, I see that neither of the equations are isolated for a variable, so substitution would not be fun to use. But I do see that there's a 2t in both equations. So I know that if I subtract 2t minus 2t, I could cancel out the t's completely. So if I choose subtraction, that means they're both positive, and so I need to use the inverse operation to get rid of the t's. But if I do subtraction, I need to do it to all of my parts. So I would do 6 subtracts 22, which gets me negative 16. 2t take away 2t goes away. And 5s subtract 9s gives me negative 4s. Now I'm only at one variable. I can divide by negative 4, divide by negative 4. S gets by itself. Two negatives divided by each other creates a positive. So I get one part of my answer, S equals 4. Now again, just like substitution, your answer needs to be in ordered pair. I need to now find out the value of t. I can choose either of these two equations and plug s back in. I'm going to pick the first one. It really doesn't matter. You'll get the same answer. The first equation was 5s plus 2t equals 6. But now I know that s equals 4. So 5 times 4 plus 2t equals 6. And then I can solve for t. 20 plus 2t equals 6. Subtract 20. 2t equals negative 14. Divide by 2. T equals negative 7. In this case, for an ordered pair, we don't know which one is an x and which one is a y. So you could leave it as s equals 4, t equals negative 7, and that would be sufficient because we don't have an x and a y. Let's look at example 2. Example 2, I see 3x plus 4y equals negative 25, and 2x minus 3y equals 6. In this case, again, I don't have any variables isolated for themselves, so I don't want to use substitution. What I don't see, though, that I had in example 1 is the same amounts of y's or the same amounts of x's. So instead of just subtracting or adding the two equations together to cancel out a variable, I'm going to first have to multiply. So I have to think. I see 3x and 2x. or I see 4y and negative 3y. I'm going to have to multiply something, or maybe both equations, so that they get to be the same amount. I'm going to choose the x's. I know that if I multiply the top equation by 2, I'll get 6x. And the bottom equation by 3, I'll get 6x also. Then I can subtract my two equations and completely cancel out the x's. So what I'm going to do is multiply the top equation by 2 and the bottom equation by 3. When I multiply, I need to make sure I still multiply every single piece of the equation. So I have 6x plus 8y equals negative 50. And I have now 6x minus 9y equals 18. Now I have the same amount of x's in both of my equations. When I have the same amount, I can either add or subtract. In this case, I would need to subtract to cancel out my 6x's. So what I'm going to do is subtract the equations. When I subtract 6x minus 6x, they go away completely. When I subtract 8y, take away negative 9y, that really becomes 8 plus 9. So that gives me 17y. And when I have negative 50, subtract 18, it gives me negative 68. Now I need to divide by 17 on both sides. Solve for y. Y equals negative 68 divided by 17, which is negative 4. Again, I don't have my final answer because that is only the y's. So now I need to choose one of the two equations that I started with, plug in my value for y, and solve for the x. Again, it doesn't matter which one. No matter what, you'll get the same answer. I'll choose the first one. 3x plus 4y equals negative 25. Now I know that y is equal to negative 4, so I'll plug in negative 4 for the y so that I can solve for only the x. This multiplies out to get negative 16. Add 16. That's negative 9. And x equals negative 3. Once more, now that I have x and y as my answers, I need to make sure I write it as an ordered pair. X coming first, y coming second, and this is my final solution, negative 3, negative 4. These are just two examples of elimination, and you have a lot more in your packet, but always refer to these and be aware that you might have to multiply both of the equations to get a matching amount of variables.